The simplest kind of symmetry, and the kind you're probably most familiar with, is line symmetry. This is where you can draw a line through a shape, and if you reflect the shape in that line, you get back the original shape in the same place. You can reflect the shape across the line without changing the shape. For example, this shape has two different lines of symmetry. I can reflect it this way across a vertical line, or this way across a horizontal line. We say it has two lines of symmetry. This arrow has only one line of symmetry, through the centre. This cross actually has four lines of symmetry, through each of the bars of the cross, but you can also reflect it through a horizontal or vertical line as well. How many lines of symmetry can you find in this star? There are 5 of them. Here's another shape that has only one line of symmetry. Now this next shape looks kind of symmetric, but it doesn't have any lines of symmetry. I cannot draw a line through the shape and reflect it over that line to get an identical image. Perhaps I need a better definition, another kind of symmetry. There is another kind of symmetry, and it's called rotational symmetry. This is where a shape can be rotated by an angle smaller than a full turn and have the image be identical, the same shape in the same position. The order of rotational symmetry is the number of times this repeats within a full 360 degrees of rotation. For example, if I rotate that first shape by exactly 180 degrees, I'll end up with the same shape I started with in the same position. And then, of course, if I rotate it another 180 degrees, I get back to where I started. We say this shape has rotational symmetry of order 2. There are 2 different positions around the full rotation where the shape looks exactly the same. The arrow cannot be rotated through any angle less than a full turn. Technically, you could say it has rotational symmetry of order 1, but since that's pretty meaningless, we usually just say it has no rotational symmetry. The thick cross has rotational symmetry of order 4. There are 4 different positions as you rotate it around where it looks the same as it did at the start. Each position is 90 degrees apart, 360 divided by the order, 4. What's the rotational symmetry of the star? Rotate it around. It has rotational symmetry of order 5. Does this teardrop shape have rotational symmetry? No, it doesn't. And now we come back to this interesting shape. Although it has no lines of symmetry, look what happens as we rotate it. It repeats every 120 degrees. It has rotational symmetry of order 3. Let's try one more. This interesting shape also has no lines of symmetry. But if you rotate it through 180 degrees, look, it's the same. It has rotational symmetry of order 2.